So dummy or qualitative variable technique. Now, when we talk about the qualitative X variables, there are again three possibilities. For example, suppose we have two groups, boys and girls, and we are considering the consumption equation where C is a function of income. So, the regression we can write as C is equal to alpha plus okay. So we are starting with this framework. Consumption is a function of income. That is CI can be modeled as alpha plus beta yi plus ui. Then we are bringing the gender aspect. GI is the gender. Okay, GI is the gender. It can take two values. Okay, so it can take two values, 1 for girls, 0 for boys. So if I implement this in the regression equation, we will get basically two equations. CI is equal to alpha plus gamma and another equation this is understandable, the last two equations I have written.
Yes, ma'am.
So CI is equal to alpha plus gamma. This equation is for boys or girls? The first
Girls.
for girls. Very good. Okay. So the notion of gender or the notion of this particular categorical variable has been captured by difference in intercepts. Consumption is a function of income in a similar fashion because I didn't change the slope coefficient. The same beta is there both for the boys and for the girls. That means marginal propensity to consume is similar between the boys and girls. However, their starting points are different. If both alpha and gamma are positive, the red line, suppose in figure 1, this is consumption. This is for girls. And this is for boys. Now, alpha may be positive, gamma may be negative. Then, the green line will be for the girls, red line will be for the boys. So it will depend on the value of the alpha and gamma, value and the signs of alpha and gamma. Okay. So hopefully you are understanding the qualitative aspect or the qualitative variable or the categorical variable. Idea of categorical variable can be captured by difference in intercepts of the two models. Difference in intercepts of the two models. Now I can bring one more category, married, unmarried. Okay. So in that case, I'll have one more qualitative variable in my basic consumption equation. Suppose I'm bringing one more category. So the equation will be Ci is equal to alpha plus beta yi plus gamma gi plus mu ami, marital status plus error. So ami indicates marital status. So ami is equal to 1. Zero otherwise. Okay. So now what I'll do, first I'll consider both gi and mi to be equal to 1. Both gi and mi to be equal to 1. So tell me what will be the format of the regression equation. So let me rub a few parts. Okay, so consider both mi and gi to be equal to 1. So what will be the regression model? Please tell me.
Ci equals to alpha plus gamma plus mu
Very good.
plus
Plus,
beta yi plus ui.
good. Then you consider mi to be equal to 0. In the same equation, you consider mi to be equal to 0. So what will be the format?
Alpha plus gamma plus beta yi plus ui.
The first equation for which group?
The first equation is for married girls.
Married girls. Very good. Second equation is for
Unmarried girls.
unmarried girls. Now we will set gi to be equal to 0. Okay, gi to be equal to 0 and mi to be equal to 1. Now I'll consider for rest of the equations gi to be equal to 0 because gi to be equal to 1 has been captured for mi is equal to 1 and mi is equal to 0. So in the next two equations, we will consider gi to be equal to 0. Now with gi to be equal to 0, first I am considering mi to be equal to 1 and then we will consider mi is also equal to 0. So if I consider mi to be equal to 1, what will be my intercept?
Alpha plus mu.
Alpha plus mu. And if I consider mi to be equal to 0, so the first one is for married boys, and second one is for unmarried boys. Okay, so when there are two categories, two categorical variables, we can generate four equations, and four equations have four different intercepts. Now, depending on the values and the signs of alpha, gamma, mu, etc., we will get a set of four lines having different intercepts, and we will be able to compare. In figure 1, girls have a higher intercept compared to the boys. So girls' consumption level will be bit higher compared to the boys always. Now, married, unmarried, depending on plus, minus, you will have a set of four lines, four parallel lines, and you will be able to compare the groups. This kind of dummy variable is called the additive dummy or intercept dummy. Additive dummy or intercept dummy. Using intercept dummies, we can consider a set of parallel lines, and looking at the length of the intercept or the size of the intercept, we can compare the groups. So not only we will be able to derive the demand curve, supply curve, savings equation, investment equation, consumption equation, now we will be able to derive this kind of equations for different types of individuals, different types of countries, different types of groups. So if I have country level data on consumption and income, okay, and we have 5 categories of countries: very poor countries, lower middle income country, upper middle income country, rich country, very rich countries. In 5 categories, if I divide the countries, that is, if there is my CI country variable along with the income variable, so using intercept dummy or using the additive dummy, we can generate a set of 5 parallel lines, and we can give some picture of, for this group of countries, this is the consumption level. For this group of countries, this is the consumption level. There is a huge gap between the very poor country and middle income countries. However, the gap is not that much between the very rich country and rich countries. So all this kind of story or project we will be able to do. Is it understandable? Anyone, any questions so far? Okay,
Ma'am,
so
you said this is sorry to interrupt.
yes,
Ma'am, you said this is called an additive dummy variable.
additive dummy variable. Yes, additive dummy variable. Okay, I'll come to the slides. We will have details of these things: additive dummy or intercept dummy. Intercept dummy is also called the additive dummy. Okay, because adding the matters alpha plus gamma plus mu, you are getting one group. Alpha plus gamma, another group. Alpha plus mu, another group. Simply alpha, another group. So all these things are coming. Now, the way I have presented the equations, if I suppose incorporate one more dummy variable, say education, consumption income relation, there is gender, there is marital status, and then education. So again, I'll be able to generate this kind of equations. However, in this way, if I continuously incorporate the qualitative variables, the question is how long we will write down the number of equations in this way. It is difficult. So we need to learn how in a single equation we can incorporate the mechanism so that, the single equation will tell us this will be the equation for the married, this will be the equation for the unmarried, this will be for, married girl, married boy, unmarried boy. So, it will be easier because in a research, sometimes we consider 10, 12 qualitative variables along with, say, 10, 15 quantitative variables. Okay, so it is not feasible always to write down the set of equations, and then tell the story. However, the idea is this: creating different intercepts and generate a series of parallel lines and comparing their intercepts. However, in the time of software, we do not have that much time to write 100 equations and then, draw the things and then understand the matters. So we have to be very careful about this, and rationally we have to put the matters in a single equation so that, we understand in a single equation we can incorporate all these dummies and all these concepts. So that much only we will learn. The background is this for the intercept dummy. The second thing is, here, when I am generating the lines, I am considering that marginal propensity to consume, that remains unchanged across the groups. That is, for the boys and girls, the interrelation between Y and X are similar. Okay. Or among different income classes, interrelationship between consumption and income is similar. So beta I am not changing. However, when we will check the real life context, under many circumstances, as we move from one group to other, interrelationship between X and Y, that also changes. Okay. So if you look at figure 2 for the same X and Y variables, if you look at figure 2, here I kept the intercept constant. Boys and girls have same intercept. They have same starting points. However, because of difference in gender, girls have a different level of MPC compared to the boys. So if I draw a parallel line parallel to x-axis, this is the MPC of girls, whereas this is the MPC of boys. Okay. So for the girls, the line is steeper compared to the boys. So this may be the situation. The most common situation is the last one, given in figure 3. It is combination of both. Both of them have different starting points and both of them have different slopes. In this case, for boys, the slope is steeper, and for the girls, the slope is flatter. Okay, so, and naturally they are intersecting at a particular point. So all these things may happen. Different starting points, however, the slope remains unchanged. Same starting point with different slopes, and different starting points as well as different slopes. Okay, so we need to learn about the fact that how to tackle the dummy variable technique when there are difference in slopes as well. So in our examples, in that case, when we will consider the married girls, the slope will be, say, beta 1. Unmarried girls, the slope will be beta 2. Married boys, the slope will be beta 3. Unmarried boys, the slope will be beta 4, along with the fact that alpha plus gamma plus mu will be the intercept for the first group, Alpha plus gamma will be intercept for the second group. Alpha plus mu will be the intercept for the third group, and alpha will be the intercept for the fourth group. So that will be the second part. How we will incorporate the difference in intercept along with the difference in slopes. Okay, along with the difference in slopes. The third important thing in context of dummy variable is when we are considering all the varieties, there will be one particular group for which the intercept itself, intercept of the original regression model will appear as the intercept. In our example, for unmarried boys, the intercept is alpha, and this alpha is the intercept of the original regression model. This alpha is the intercept of the original regression model. Okay, so what we are finding that, and when we had lesser dummy variables, we had gender. If you look at the equation for the girls, the intercept is alpha plus gamma, whereas if you look at the equation for boys, the intercept is alpha. So what we are finding that the intercept of the original model is appearing as intercept of one of the groups we are considering. Okay, so this is also very a typical thing in context of dummy variables, and for this matter we need to avoid the concept of dummy variable trap. So that in the third section I'll discuss about the notion of dummy variable trap. Okay, incorporating this idea that for one of the groups, the intercept will be the intercept of the original model. So three things we will learn in this course regarding the dummy variable. First of all, that these dummy variables are only the explanatory variables. Explained variable is still continuous in nature. In this context, we will learn three things: how to analyze the intercept dummies, next, how to analyze the slope dummies, next, what is meant by dummy variable trap. So let's move to the slides. Okay, so already these things are discussed in statistics and economics, particularly in regression analysis. A dummy variable is one that takes the value 0 or 1 to indicate the absence or presence of some categorical effect that may be expected to shift the outcome. Okay, so in other words, dummy variable is a binary variable. The way we are constructing the dummy variable, it has two layers. It is a binary variable. They can be thought of as numeric stand-ins for qualitative facts. In a regression model, sorting data into mutually exclusive categories, such as male, female, smoker, non-smoker, married, unmarried, So in this way, once created, these proxies or dummies are used in regression analysis just like other explanatory variables, yielding standard OLS results. As I mentioned, as long as the explanatory variable is a dummy variable, you will be able to apply the ordinary least square technique. The values of the variables can be only 0 and 1, the binary structure. However, there will be no difference in the method of estimation. So you will be able to apply the least square technique, and you will be able to estimate the parameters of the model. Already you did this thing in your Excel, so you have some idea about dummy variables. When you are incorporating the dummy variables, you are using the least square technique and estimating the model. The interpretation of the coefficient will be a bit different from that of the interpretation of the coefficient of a continuous variable. However, there will be no difference in estimation technique. The econometric literature abounds with example of use of dummy variable. The demand for specific good, example mineral water, may vary between urban and rural districts. The demand for labor from an industry may show seasonal variations. The wages paid to men and women may reveal variations which are not to be explained by variables like education, experience, skill, age, etc. Okay, so there may be a particular element, the qualitative aspect, okay, or gender bias, okay, gender bias. Okay, so all these things are there. These are the examples. Regularly in economics, we need to model different context using this kind of qualitative variables. So already I discussed these graphs, for, here I am considering the wage experience, this kind of modeling. Age indicates experience, so salary or the wage depends on experience. For male, we are getting higher starting point. For female, we are getting lesser, or lower starting point. So there is a gender bias. They have given the same level of experience, given the same level of experience. If you consider this experience, this is the female wage, this is the male wage, So this is a possibility. The second diagram indicates, same starting point. However, for male wage rate is increasing fast with respect to experience. For female, it is slower. The third example, male and female has different starting point. Along with that, with experience, the wage of male that increases at faster rate compared to the female. Okay. So let's first talk about the additive dummy. Suppose we have data on aggregate consumption and income of 1,000 individuals, 750 of whom are married and 250 unmarried. We may formulate the consumption function as follows to present the choices of 1,000 individuals. Yi is equal to alpha plus beta xi plus epsilon I. I is moving from 1 to 2,000, where yi and xi refer to the aggregate consumption and income of the ith individual, just the example we considered. However, it could be reasonably felt that consumption pattern of the two groups will vary. For example, the married may want to consume less than the single for a given level of income. For the married individual, responsibility is higher, so they may want to save, and therefore their consumption level may be lesser. For unmarried individual, responsibility is lesser, so whatever they are earning, they will like to spend. Suppose this is the background. One way to allow for this difference is to use two separate regressions. That is, yi is equal to alpha 1 plus beta 1 xi plus epsilon I for, say, married group, and yi is equal to alpha 2 plus beta 2 xi plus epsilon I for the single group. Two conceivable situations now arise. Number one, two equations differ only in their intercepts. That is, marginal propensity to consume that is similar across the groups. However, they have the different starting points. Number two, Two equations differ in both slope and intercept. Additive dummies can conveniently handle the first of the above two situations. The two equations are rewritten assuming a common slope yi is equal to alpha 1 plus beta xi plus epsilon I, and yi is equal to alpha 2 plus beta xi plus epsilon I. These equations can be combined by introducing a dummy variable d such that di is equal to 1 if the individual is single and 0 otherwise. The combined equation is yi is equal to alpha 1 plus alpha 2 minus alpha 1 di plus beta xi plus epsilon I. So this is the way, we can handle the thing. Alpha 1 plus alpha 2 minus alpha 1. Okay. So, for different groups, we can consider a value and then we have to subtract that value from the first intercept or given intercept in this format. Now for this format, if you set di to be equal to 1, in that case the intercept will be alpha 1 plus alpha 2 minus alpha 1. So alpha 1 will be cancelled. You will get the intercept to be alpha 2. Okay, and di is equal to 1 if the individual is single. So for this group, the intercept is alpha 2. Alternatively, if you set di to be equal to 0, this entire term will vanish and the intercept will be alpha 1. So we can accommodate both the groups in a single equation using the dummy variables. In that case, we have to write the coefficient in the form of difference, from the reference category. The intercept of the original model will be considered as the intercept of the reference category. Here, the reference category is the married individual. With respect to married, we are comparing the other group unmarried. So intercept, the group for which the intercept of the original model will appear as the intercept is called the reference category. Reference category. So married individual is the reference category. Di is equal to 0 for the married individual. So married individual is the reference category for which the intercept, is the original intercept is the intercept. For rest of the groups, it will come as the difference from the reference category, difference of the intercept from the reference category. So this format, alpha 2 minus alpha 1, this format. Then plus beta xi, beta I am keeping unchanged for both the groups, therefore beta xi plus epsilon I. When di is equal to 0, we get back the equation of the married, and when di is equal to 1, we get the equation of the single. So equation 1 can be rewritten as yi is equal to alpha 1 plus delta di plus beta xi plus epsilon I, where delta is the difference between the intercept of the two groups, or difference of the intercept of a particular group from the intercept of the reference group. Difference of the intercept of a particular group from the intercept of the reference category, reference group. Equation 2 can be estimated using the ordinary least square technique, considering xi and di are two regressors of the model. Delta, which is equal to alpha 2 minus alpha 1, indicates the excess of intercept for single individuals over that of married. Okay. However, whether the intercept for the married individual will be higher or intercept of the unmarried individual will be higher. It will depend on the values and the signs of alpha 1, alpha 2. Similar type of model can be framed for two different time periods or two different socio-economic scenarios like war and peace, etc. The use of multiple dummies raises no new issue on principle. If we introduce the sex difference along with the marital status, equation 2 can be rewritten as yi is equal to delta 1 d1i plus delta 2 d2i plus beta xi plus epsilon I. So in a single equation, we are incorporating more and more dummies, okay? D1i is equal to 1 if the ith individual is male, D1i is equal to 0 if the ith individual is female. D2i is equal to 1 if the ith individual is single, D2i is equal to 0 if the ith individual is married. Okay, now setting D1i is equal to 1, we will get alpha 1 plus gamma 1, D1i is equal to 0, we will get alpha 1. Along with that, if I consider D2i to be 1, the values will be added and will give us newer and newer values of the intercept. So all the dummy variables in this way can be accommodated in a single equation, and then if I write the meaning of the things, we will be basically able to generate a set of equations as we got in the earlier example. Beta is the common slope coefficient, alpha 1 is the intercept of the married females, alpha 1 plus delta 1 is the intercept of the married males, alpha 1 plus delta 2 is the intercept of single females, alpha 1 plus delta 2 is the intercept of the single males. So this is the notion of additive dummy. Okay. Now, for a particular variable here, both for D1i and D2i, conceptually, two categories are possible: male, female, single, married, So there may be education variable for which there are, say, 4 layers, education variable. Suppose education is a dummy variable. So suppose there are 4 categories for this variable education. Okay. For when there are 4 categories, we have to create 3 dummies. So Okay. So what do we have to do? I have to rewrite this equation as okay. So, you have more than two categories for the variable. For that, you have to create several binary dummies. For that, I have 4 layers of education. And for that matter, I have created 3 binary dummies. 3 binary dummies. Okay. Now here, if I consider D1I is equal to 1, D2I is equal to 1, D3I is equal to 1. Okay. In that case, I have to consider the equation as yi is equal to alpha 1 plus delta 1 plus delta 2 plus delta 3. This will be the intercept. If D3I is equal to 1, 0 otherwise. So for all the dummy variables, I have to consider rest of the dummy variables with respect to education. I have to consider 0 values. Similarly, if I said D4I is equal to 1, in that case, D3I, D5I will be equal to 0. If I consider D5I equal to 1, in that case, I have to consider D3I and D4I to be equal to 0. Okay. So for different education level, and if I set D3I, D4I, D5I all equal to 0, we are getting the intercept for primarily educated individuals. If I set all D3I, D4I, D5I equal to 0, we will get the equation for individuals having primary level of education. Okay. So, number one, if I have several categories, we have to construct a number of binary dummies to capture several categories. However, whenever I am constructing the dummy variables for each of the variables, I am considering one dummy less. I am considering one dummy less. For example, when I have 2 categories for the variable sex or gender, I am defining one dummy variable D1I. D1I is equal to 1 if male 0 otherwise. When I have again a variable like marital status, when there are 2 categories, I am defining a single dummy variable D2I. D2I is equal to 1 if the individual is single, 0 otherwise. Next, if I have a variable like education, and suppose there are 4 categories in the variable, I am defining 3 dummy variables, D3I, D4I, D5I. D3I is equal to 1 if secondary, 0 otherwise. D4I is equal to 1 if HS, 0 otherwise. D5I is equal to 1 if graduate, 0 otherwise. Okay, so looking at the educational qualification, we have to consider whether D3I will be equal to 1, D4I will be equal to 1, or D5I equal to 1. If we find that none of these dummy variables will be equal to 1, we will not incorporate any education dummy. In that case, intercept of the original model or combining the other intercepts, etc., we will get the layer for primary education. Okay, we will get the layer for primary education. For example, if I consider D3i, D4i, D5i, all three equal to 0, and D1i and D2i to be equal to 1, the intercept will be alpha 1 plus delta 1 plus delta 2. And that is the intercept for primarily educated single male. Primarily educated single male. Okay, suppose D2i is equal to 0. In that case, it is indicating, then the intercept is alpha 1 plus delta 1. D3i, D4i, D5i all equal to 0, and along with that D2i is also equal to 0. That is indicating, I'm considering the intercept for primarily educated married male. Primarily educated married male. Now, if D1i, D2i both are equal to 0, along with D3i, D4i, D5i equal to 0, that indicates married female primarily educated. Alpha 1 is the intercept of married female primarily educated. Primary educated married female, for them the intercept is alpha 1. So whatever be the case, what we are finding that we are defining one dummy less. If there are two categories in a variable, I am defining one dummy. If there are three categories, I'll define two binary dummies. If there are four categories, I'm defining three binary dummies. So I am always defining one dummy less. The statement is, if originally there is intercept term in the regression model, originally if there is an intercept term in the regression model, we have to define one dummy less. Otherwise, we will face the problem of dummy variable trap. Otherwise, we will face the problem of dummy variable trap. Now, we are going to understand what is meant by dummy variable trap. So first look at the note. We have two gender categories but have introduced only one dummy variable D1 to account for them. Similar thing has happened for marital status. Similar thing has happened for education. So this we have done to avoid the dummy variable trap. To understand the notion of dummy variable trap, let's consider equation 2. This is equation 2, where I have a single dummy, married, unmarried, DI. Or D1i. D1i is equal to 1 if the individual is single, 0 otherwise. Again, I am setting another dummy. D2i is equal to 1 if the individual married, 0 otherwise. Okay, so for the two categories now, I'm defining two dummies equal to 1 if the individual is single, D2i is equal to 1 if the individual is married. So for the two categories, I'm setting two dummies. Note that D1i plus D2i is equal to 1 for all I. D1i plus D2i is equal to 1 because these are mutually exclusive. So when D1i is equal to 1, D2i is equal to 0, D1i is equal to 0, that means D2i is equal to 1. These categories are mutually exclusive. So when you are defining two dummies, when one dummy will take the value 1, the other dummy will take the value 0. Okay, so sum of these two dummy variables D1i plus D2i is equal to 1 for all I. Hence, instead of equation 2, Or equation 2 is rewritten as yi is equal to alpha plus delta 1 d1i plus delta 2 d2i plus beta xi plus epsilon I. This is equation number 4. The X matrix is now given by the first column 1, 1, 1, 1, 1 n times, the 1 will appear, that is for alpha. And then we have the xi variable, x different observations of x variable, x1, x2 to xn. Then we have different observation for d1, d11, d12, it will move up to d1n. Different observations for d2, d21, d22, and it will move up to d2n. So we are getting a matrix of order number of rows is equal to n and number of columns, that is equal to 4. So k is equal to 4 here. So we are getting one n by 4 matrix, n by 4 matrix. Now here, if I add the last two columns, the third and the fourth columns, we get the value to be equal to 1 because d1i plus d2i is equal to 1. This is similar to that of the first column. Hence, the determinant of x is equal to 0. Non-singularity property will not hold. The determinant of x will become 0. So x, it does not have the full column rank. The X matrix does not have the full column rank. So this is one of the very important assumptions in context of k-variable analysis. All the columns in the X matrix should be independent to each other. All the columns of X matrix should be independent to each other. Now, if determinant X is equal to 0, in that case, we will be not able to calculate X prime X inverse, and for that matter, we will be not able to apply the OLS technique to derive the values of beta hat, because beta hat is X prime X inverse X prime Y. So all these consequences will be there. This is known as dummy variable trap. This is known as dummy variable trap. So if originally there is intercept in the regression model, always consider the number of dummies for one particular variable, one less compared to the number of categories it has. If it has 2 categories, define 1 dummy, 3 categories, 2 dummies, 4 categories, 3 binary dummies. Okay, so 1 dummy less. Look at the variable, look at the number of categories it has, and you have to define 1 dummy less. Otherwise, you will face the problem of dummy variable trap. And dummy variable trap has serious consequence because one of our very vital assumption will no longer be satisfied. X matrix is will no longer have the full column rank. This is number one. And there will be some problem regarding the matrix inversion, and we will be not able to derive the estimated values of the parameters using the least square technique. So all these things are there. Okay, so this is all about the additive or the intercept dummy and the notion of dummy variable trap. Now, one more thing we have to discuss, that is the multiplicative dummy or the slope dummy. Any questions so far? Starting from, very beginning up to this. Anyone, any question? Any part I need to repeat?
Ma'am.
Yes.
Ma'am, could you go back to the last slide? No, ma'am, a few more slides ahead, I think.
This one?
Yes, ma'am. Ma'am, so on this slide, ma'am, you said that if D4I is equal to 1, then D3I and D5I will be equal to 0, right?
Yes.
Ma'am, but if D4I equals 1, shouldn't D3I also be equal to 1 because he has already come past the secondary level, right?
We are considering all the groups to be mutually exclusive.
Okay.
Okay.
Okay, ma'am.
So, primary means up to primary, secondary means up to secondary, HS means up to HS. Okay. So, if you are up to HS, it is true, you have done all these things. However, you belong to that category. All the categories are mutually exclusive.
Ma'am,
Yes.
বলছি ডামি ভেরিয়েবল ট্র্যাপটাকে রিমুভ করার জন্য কি করতে হবে একবার বলবেন?
ওয়ান ডামি লেস ধরতে হবে। ধরো তুমি একটা যে কোনো ভেরিয়েবল নিলে, এবার দেখে নিলে সেই ভেরিয়েবলের জন্য কটা ক্যাটেগরি আছে। জেন্ডার যদি একটা ভেরিয়েবল হয় তাহলে তার দুটো ক্যাটেগরি আছে। যে তোমার ম্যারিটাল স্ট্যাটাস যদি একটা ভেরিয়েবল হয় তার দুটো ক্যাটেগরি আছে। ওকে, এবার তুমি যদি ডিভোর্সি আর একটা ক্যাটেগরি ধরো, সেটা আর একটা ধরতেই পারো, কারেন্টলি ম্যারিড, ডিভোর্স, আনম্যারিড, এরকম করতে পারো। ওকে, সো ইটস নট দ্যাট যে এখানে আমি ধরেছি দুটো ক্যাটেগরি। সো there may be more than two categories for the marital status. এডুকেশনে আমি চারটে ক্যাটেগরি ধরেছি। এডুকেশনে আরো অনেক ক্যাটেগরি করে দেওয়া যেতে পারে, মাস্টার্স, পিএইচডি, তারপরে যেরকম আমরা করি যে বেসিক এডুকেশন, টেকনিক্যাল এডুকেশন, এরকম। অকুপেশন ধরো একটা ভেরিয়েবল ধরলে অকুপেশনের 10-15 ক্যাটেগরিজ করা হয় অনেক সময়। সো অল দিস থিংস আর দেয়ার। সো একটা ভেরিয়েবল নিয়ে নিলে ভেরিয়েবলটায় কতগুলো পসিবল ক্যাটেগরিজ তোমার মডেলে আছে সেটা তুমি দেখে নিলে। তোমার জেন্ডারের জন্য কটা ক্যাটেগরি আছে, ম্যারিটাল স্ট্যাটাসের জন্য কটা ক্যাটেগরি আছে, এডুকেশনের জন্য কটা ক্যাটেগরি আছে, অকুপেশনের জন্য কটা ক্যাটেগরি আছে, তুমি সেগুলো দেখে নিলে। ওকে, এবার ওই যতগুলো ক্যাটেগরি থাকবে তার থেকে একটা লেস ডামি ভেরিয়েবল তোমাকে ক্রিয়েট করতে হবে if originally there is intercept in the regression model. If originally there is an intercept in the regression model, you have to create one dummy less for each of the variables looking at the number of categories you have. Total category jodi 6 ta hoy for a particular variable, you have to create 5 binary dummy variables. Total category jodi 3 hoy, you have to create 2 binary dummies. ঠিক আছে? আর একটা ভেরিয়েবলের জন্য যতগুলো ক্যাটেগরি তুমি ক্রিয়েট করলে সবগুলো কিন্তু মিউচুয়ালি এক্সক্লুসিভ। মিউচুয়ালি এক্সক্লুসিভ, জিরো আদারওয়াইজ লিখছো মানে যখন ওই ভেরিয়েবলের ওই ক্যাটেগরিটাকে 1 ধরছো, জিরো আদারওয়াইজ বাকিগুলোকে সব জিরো কনসিডার করতে হবে। ওকে, সো ওই মিক্সিং ম্যাচিং হবে না, তোমার জিরো ধরে নিতে হবে, বিকজ জিরো আদারওয়াইজ। ঠিক আছে, সো এই ম্যাটারটা যে একটা করে ডামি লেস ধরতে হবে, টোটাল ক্যাটাগরি যা আছে তার থেকে একটা ডামি লেস ধরতে হবে। তুমি যদি মেলের জন্য একটা ডামি, ফিমেলের জন্য আবার একটা সেপারেট ডামি D1I D2I ধরো, এডুকেশনের 5টা লেয়ার আছে তার সবগুলোর জন্য তুমি যদি D3I D4I D5I D6I ধরো, তাহলে সেক্ষেত্রে তোমার ওই যখন সবকটা ডামি ভেরিয়েবল কলামে চলে আসবে, এখানে যেমন ধরো জেন্ডারের জন্য এসেছে, এবার ম্যারিটাল স্ট্যাটাসে যদি তুমি দুটো করো D3 D4 চলে আসবে, এডুকেশনে যদি 4টে করো 5 6 7 8 চলে আসবে, ওগুলোর তো সামগুলো সব 1 হয়ে যাবে, বিকজ এগুলো মিউচুয়ালি এক্সক্লুসিভ বলে সামগুলো 1 হয়। এবার সামগুলো 1 হয়ে যাওয়া মানেই এইটা এই যে ফার্স্ট কলামটা তো 1 1 1 1 করে গেছে, তাহলে তুমি কলামস গুলো ইন্ডিপেন্ডেন্ট নয়, matrix does not have full column rank, and for that matter there will be some serious problem in estimation technique. That is the idea. So this is called the dummy variable trap. বলো আর কিছু বুঝতে পারলে কিনা লক্ষদীপ বা অন্যরা?
ইয়েস ম্যাম, বুঝেছি।
অন্যদের কারুর
ম্যাম
question?
যদি অরিজিনাল ইকুয়েশনে ইন্টারসেপ্ট না থাকে তাহলেও কি ডামি ভেরিয়েবল ট্র্যাপ
এইটা
হতে পারে?
প্রত্যুষ বলছে, এইটা আমি প্রত্যুষ বলবো এবার। এই এত বাকিরা বলো সব বুঝতে পারা গেছে কিনা, কোনো জায়গা রিপিট করার দরকার আছে কিনা? এবারে যেটা প্রত্যুষ has asked, যে সাপোজ আমার অরিজিনালি ইন্টারসেপ্টটা ছিল না রিগ্রেশন মডেলে, there is no alpha there, original regression model is passing through the origin. In that case we do not have these 1 1 1 1 column. Okay, in that case we have to define dummy for each of the categories separately. Okay, তখন আমার কি হচ্ছে, যখন আমার এই 1 1 1 1 থাকছে না, তখন আমি যদি d1i is equal to 1 for one group and d2i is equal to 2 for another group এইরকম ভাবে ধরে নিই, তাহলে আমার যখন ফিমেল হচ্ছে আমি তখন একটা কলাম পাচ্ছি, আর মেল হলে আমি আর একটা ভ্যালুজ এর কলাম পাচ্ছি। ওকে, তাদের সাম ইজ ইকুয়াল টু 1 ম্যাচিং হয়ে এটার সঙ্গে যাচ্ছে, সেই সমস্যাটা আর থাকছে না। Okay, in that case we can create the dummies according to number of categories we have. If originally I do not have the intercept term in the regression model, so that I do not have this first column in the X matrix, then we can define the separate dummies for all the separate categories. In that case we will be able to define dummies, separate dummy variables for all the separate categories. তখন কিরকমটা হচ্ছে এই ইকুয়েশনে, ধরো তোমার d1i টা মেলে, d2i টা ফিমেলে, এবার d1i যখন 1 হচ্ছে তখন তোমার ইন্টারসেপ্ট হয়ে যাচ্ছে ডেল্টা 1, আর d2i টা যখন 1 হচ্ছে তখন তোমার ইন্টারসেপ্টটা হয়ে যাচ্ছে ডেল্টা 2। ওকে, d2i টা 1 হচ্ছে মানে d1i টা 0, তখন তোমার ইন্টারসেপ্টটা হয়ে যাচ্ছে ডেল্টা 2, মানে একবার একটা ডেল্টা 1 হচ্ছে, একবার একটা ডেল্টা 2 হচ্ছে। তোমার তো এই জিনিসটা তখন নেই, এই জিনিসটা তখন নেই। সো সেপারেট ইন্টারসেপ্ট পাচ্ছি, সেটিং d1i is equal to 1 0 otherwise, setting d2i is equal to 0 otherwise. Okay, so then this is possible that we will define separate dummies for separate categories of a variable. Anyone, any question?
Ma'am, so in that gender example, if we have like two categories, like in this case, male and female, so one category, so one dummy variable, say d1i, will be equal to 1 if male and 0 otherwise, and we'll have d2i equal to, if female, it's 1 and equal to 0 otherwise. Right. Okay.
তখন তোমার x1 x2 xn আর d11 12 1n এদের এবং d21 d22 d2n কে একসাথে রাখতে কোনো অসুবিধা নেই, বিকজ ওদের সামটা তো 1 হবে সব সময়। যদি এটা 1 1 গুলো হয় এগুলো সব 0 0 0 0 হবে, এটা 1 1 হলে এটা সব 0 0 0 হবে, সামটা সব সময় 1 হবে, কিন্তু সেই 1টা তো কোনো কলামের সঙ্গে গিয়ে ম্যাচ করছে না। ঠিক আছে আরাত্রিক?
ম্যাম এই লাস্ট পার্টটা একবার এক্সপ্লেন করবেন, কলমের সঙ্গে ম্যাচ করছেন ইন দ্য সেন্স?
দেখো তোমার তখন এক্স ম্যাট্রিক্সটা অরিজিনালি কিরকম ফরম্যাটে আছে? Suppose we are considering the equation for the girls. তখন তোমার এক্সটা সাম করলে এই ওয়ান এইসব কন্ডিশন সব থাকবে, কিন্তু এই যে সাম করলে ওয়ান হচ্ছে সেটা তো কারোর সঙ্গে গিয়ে ওভারল্যাপ করছে না, ঠিক আছে? কলামস গুলো ইন্ডিপেন্ডেন্ট হচ্ছে।
হ্যাঁ, তখন এক্স ট্রান্সপোজ এক্স ইনভার্স এক্সিস্ট করবে।
হ্যাঁ, আমার চাই ফুল কলাম র্যাঙ্ক, সো কলামস গুলো তখন ইন্ডিপেন্ডেন্ট থাকছে। ওকে, বিকজ ভেরিয়েবলস গুলো সব ইন্ডিপেন্ডেন্ট। এদেরকে ক্লাব করে আমি কোথাও পাচ্ছি না যে ওই একটা অরিজিনাল কলাম তার সঙ্গে ম্যাচ করে যাচ্ছে। So if the columns are independent, that is the matrix have full column rank, then there is no problem. However, if the matrix does not have full column rank, in that case, there is a problem. You will be not able to calculate inverse. Everything is coming then. Okay. So this is the thing. In the earlier case, there was a trap. If you consider two dummy variables for two categories of a variable, you will face a trap. However, in the last case, when there is no intercept term, there is no trap at all. আরো যদি কিছু কোয়েরি থাকে, কোয়েশ্চেন থাকে কারুর, প্লিজ। So next is the multiplicative dummy, or the slope dummy. It is more likely that both intercept and slope will vary across different groups. Thus, the initial equations are yi is equal to alpha 1 plus beta 1 xi plus epsilon I for married. And for the single, the equation is yi is equal to alpha 2 plus beta 2 xi plus epsilon I. So not only they have the different starting point, but also their slopes are different. Their slopes are different. Okay, beta 1 and beta 2, the slopes are different. To introduce the dummy variable, we will consider di to be equal to 1 if the ith individual is single, 0 otherwise. Okay, 0 otherwise if the individual is married. We also introduce another dummy variable, a new dummy variable or a new variable. Say w is equal to dx. W is equal to dx, di into x. Equation in that case is rewritten as yi is equal to alpha 1 plus delta 1 d1i, where delta 1 is equal to alpha 2 minus alpha 1, plus beta 1 xi plus delta 2. Delta 2 is beta 2 minus beta 1. It's the same concept. We are applying, the difference between the slope or the gradient coefficient of the current group and the reference category. Group 1, that is the married individual, is the reference category. considered as reference category. Okay, so we are considering, when I am considering alpha 2 minus alpha 1, this indicates okay, beta 2 minus beta 1, same concept. Here the difference in intercept and here the difference in slope. এইটা হয়ে যাচ্ছে difference in diff in intercept আর এটা হয়ে যাচ্ছে difference in slope. So rest of the things are same. I'm bringing another dummy variable wi. Okay, another dummy variable wi. Okay, wi introduces an interaction between the dummy variable and the explanatory variables. It is product of dummy variable and the explanatory variable. So it is creating an interaction between the dummy variable and the explanatory variable. Okay, so it is an interactive dummy. It is multiplicative dummy, is also called the earlier one was the intercept dummy. This is called the interactive dummy or slope dummy. So these are the names. It involves an interaction between the dummy variable and the concerned x variable. Okay, so what we are doing, yi is equal to alpha 1 plus delta 1 d1i plus beta 1 xi plus delta 2 wi plus epsilon I. So there is a typo, So now you set d1i is equal to 1. Okay, d1i. This will give you the equation. This is the intercept. Am I right? When di is equal to 1. Am I right? Are you understanding this?
Yes, ma'am.
Others?
Yes, yes.
Alternatively, This is the group. This is the equation. Okay, so between the single and the married, both the intercept and the slope varies. Between the two groups, both the intercept and the slope varies. Okay, so for single, the equation is yi is equal to alpha 1 plus delta 1. This is the intercept, plus beta 1 plus delta 2. This is the gradient into xi plus epsilon I. Whereas for the married, the equation is yi is equal to alpha 1 plus beta 1 xi plus epsilon I. So in this way, we can apply interactions, or we can use the multiplicative dummy to introduce the difference in intercept as well as difference in slopes. Now, if between the two models only there is a difference in gradient, however, their starting point is same, that will be the subset of these kind of analysis. In that case, the common intercept will be alpha, and we have to define only w into dx, where d is equal to 1 if the individual is single and 0 married. However, that will not affect the intercept term, because intercept term is common, that is alpha. So suppose the equation is yi is equal to alpha beta 1 xi plus epsilon and alpha plus beta 2 xi plus epsilon. So if this is the construct, in that case, for both the groups, the intercept will be alpha. So the regression model will be given by yi is equal to alpha plus xi this will be the construct. This will be the construct. Other things remaining unchanged. This will be the construct of the equation if the intercept does not vary between the group, only the slope varies. There is no variation in the intercept, however, only there is a variation in the slope. So for one group, the regression equation will be given by yi is equal to alpha plus beta 1 xi plus epsilon I, whereas for the other group, it will be given by yi is equal to alpha plus within bracket beta 1 plus delta 1 xi plus epsilon I. That will be the thing. Okay, so when there is no difference in intercept, only the difference in slope. No difference in intercept, only the difference in slope. So this is all about the multiplicative dummy or interactive dummy, or the notion of interaction, etc. Any question?
That last bit you did, that was for the slope dummy, right?
Only slope dummy. Yeah, there is no difference in the intercept. Both the cases are related to the slope dummy. However, in the last case, the two lines have two starting points, same starting point, sorry. This is the case. This refers to the last case. Only the difference in gradient, there is no difference in intercept. Now for these, ideas of what is meant by dummy variable, what is meant by intercept dummy or additive dummy, what is meant by slope dummy, interactive dummy, and what is meant by dummy variable trap, for this part, for this introductory course on dummy variable, again, you follow Madala's book. It will be easier for you to understand. Madala's book is good for this part. So don't go for the part when they are considering the yi is qualitative in nature. We have in our syllabus the notion of dummy variable when xi is qualitative in nature. Okay, xi is qualitative in nature, not yi. And already, I think in the practical class, you handled this kind of dummy variable. Am I right?
Yes, ma'am.
In,
We work with binary
you,
variables.
yeah, in some other class, you mentioned that already you did the dummy variables. So if there is any gap in the theory and practical, anything I need to repeat, please let me know. So I'm discarding all these changes. Do you need anything? If you need, please write down. Otherwise, I'll discard all these changes. Should I discard? Have you taken note of these facts?
Yes, ma'am.
Okay, so this is all about the dummy variables. I'll not proceed further. This is more than sufficient for your class. Now the analysis, the understanding, the matters, looking at regression model, if you can tell how many groups are there, several numerical exercises we need to discuss, that's all. This is more than sufficient for your class. So do anyone have any question?